Hello, everybody, and welcome to this presentation. Really glad to see everyone here. Uh, I'm going to be talking about Agile property graph design process. First, a little bit about myself. My name's John Singer. Once again, appreciate Neo4j having me here, and appreciate all you being here. So, my name's John. I'm a recovering IT worker, some 40 years of experience, primarily in data architecture roles. A lot of time as data administration, data modeling, been some DBA work, a lot of metadata work. Last few years, I worked on what's an ITIL CMDB. And if you're not familiar with that term, CMDB is a configuration management database. And basically, it's a knowledge graph of all your IT architecture. So that was an interesting effort to work on. And that's where I kind of became aware of Neo4j and graph databases. The vendor that we were working with, one of those three-letter acronym companies, the tool they had for the CMDB, of course, was built on a relational database. And yet the model was clearly a graph. You described everything in terms of you had objects and they had relationships to other objects. And they all had properties. So it was a graph. And yet they implemented it on relational. And this produced an absolute nightmare of SQL that you had to write to get anything useful out of it. And so that's where I started to discover graph technology. I ran into Neo4j, was kind of its earlier years, and I realized what a great solution this was to the CMDB problem. So, Emil in his keynote talked about what his favorite use cases were. Well, this one's mine. This is the only one you need to know to prove that graph database is better. So I started working with Neo4j and quickly discovered that the tools I was used to having didn't exist. So primarily in data modeling and data management query, data modeling tools. So I started a company to build those, and that's where what I'm doing today. And welcome everyone to come by and take a look at what we're doing. So here's my contact info. Hit me up on LinkedIn. Love to hear from you. So we're here to talk about property graph data modeling. What I'm going to be focusing more on is the process and not necessarily what's a good property graph versus a not so good one. But I'm going to be going through more, how do I create a data model? What's the process? What is exactly a data model? And of course, the big question, and you get this from developers, why do I even need to do this? So hopefully we'll address all these, and maybe I can make some converts. So first, let's start with a little context setting. When we talk about information or data modeling, what we really want to strive for is we want to define what the data means. And that's what the phrase what not how is referring to. So we want to talk about the what of data, not necessarily the how we're going to use it or how it got there. And we want to do this in business terms to the extent that's possible. And our goal is to create a shared resource. So the only way you can do that, have a data model that's really can be shared, is it has to be process neutral. And there's a concept called the three schema architecture that attempts to kind of describe, what this is and why we want to do it. And the observation is that we really, in an application, there's really kind of three different schemas at play. There's the storage view, which is really just the physical layout or the physical access methods to how data is stored. Um, there's the user's view, which there's a lot of different forms of user's view. Obviously, there's different reports. They want to see data on the screen differently, reports, visualizations. Now, of course, which is new and important. Um, and each one of those users views really represents a specific slice through the overall network of data. And and what in the earlier days, what the mistake people will make, and I think we still tend to make this mistake today, is you look at a user view and you map that right down to your storage, and you build a data design strictly for a particular user's view. And when you do that, it's not reusable, it's not shareable, and you're ultimately going to have to be constantly redoing it. So what we really are striving for is this thing in the middle, which is the conceptual view. And we want to define data in that way so it's reusable. And really, that's our goal. We want to translate the business requirements into a property graph design. And I put property graph in brackets there because if that's your primary target, that's what we're designing. In the relational world, kind of the traditional world, we're probably going to translate business requirements into an entity relationship model. That's I guess you could say, the more traditional or typical approach. So at any rate, that's our goal. And we want this to be a collaborative effort, obviously. And we need to involve, this is where, in a big way, we can get the business involved in what we're doing. All right, so first idea, we're doing what, not how. So the second big idea is to think about where do we fit this, where does this data modeling activity fit in kind of the overall process of designing and engineering the system that we're building. And to do that, we look at something that's referred to as the Zachman framework. Now, Zachman defined this framework. Basically, he wanted to answer the question of why is it that we have so much problem getting complex software systems to work? Or why are there so many failures in complex software systems when it seems that we have a very good ability to build other complex engineering products? And so he went and what he did was he went and studied the aircraft industry. Obviously, a jet airplane is a very complex product, and they managed to build them very successfully and build them and fly them very successfully. So he went and looked at that. He also looked at the architecture and building industry to see how they did their job. We build complex towers, tall skyscrapers. They all seem to stand. Well, maybe there's that one in San Francisco that's leaning, but we'll ignore that. So let's go look and see how these other aircraft industry or the building industry, how is it they're able to build complex engineering products and be successful at it? So he went out and did this, he studied what they did, and he came back and really with kind of two epiphanies, if you will. And one is that his observation was that the design process really takes place in layers, and these layers are different viewpoints. So I've kind of simplified his model here, but there's an owner layer, a designer layer, and a builder layer. And so, we create a design for the owner, but it's very high level. At the designer level, we bring that down to a greater level of specificity, a greater level of detail, and really we want enough design detail that we can hand it to the people who actually build the systems and have them be successful. So he recognized that you have to have these different layers represented. The other thing he saw was that as a part of the design process, there isn't just one design. There's actually a design for each of the who, what, how, why, where, and when. And these are actually different artifacts that are created to answer these different questions. And so that's why he lays it out, and those are the columns. And so that's why he lays it out this way. And each cell, so each cell in this grid represents a different design artifact. And this, like I say, this is what he observed in other businesses that are successful, and he applied this to the IT world and to the notion of building software systems. And so you can find this online. There's the complete diagram, and you'll see in each one of these cells the different IT artifact that should be produced in each one. So those were his kind of the epiphanies, and that's what, where we want to try and focus in terms of our process of building a data model. And we're operating right here. We're in the what column. Remember, it's what, not how. Of course, the how is important. We need to look at use cases, data questions. These are derived from our strategy, our goals, our business processes that we get from our owners. So this is all important input, but we're focusing on the data model. And we're at the designer view, we're defining the what, and we're trying to bridge that gap between the owner and the builder. All right, so let's just take a quick kind of a linear view at the process. Starts with, we're going to look at our objectives. We're going to create some high-level domain requirements. That's to say, what are the subject area and what are the main entities in the application, writing in use cases and data questions. So this notion of data question is really useful because it helps crystallize, what story does the data need to tell, and you pose that in the form of a question. And the beauty of that then is you can then later validate it by writing queries that answer the question. So use cases and data questions, that becomes kind of an input. From that, we can go into building instance data prototypes or storyboards. Now, you might do this on a whiteboard, paper and pencil, but the idea is to actually key in actual instance data that demonstrates that it's meeting the requirements. And once you do that, you can validate it. Like I said, you can write queries against that data to answer the questions, or you can at least show diagrams that answer the questions. Once you're satisfied with that, you can then move on and describe node and relationship templates or types. And this is, in some sense, and at least today, is really kind of more documentation. There is no notion there's no create node statement in Neo4j like we have in the relational world, because Neo4j is a schema on demand, if you will. So we don't have to predefine what a node looks like in order to create one in the database. That's actually one of the great advantages. It's a great risk. It's also a great advantage. But we need to describe these patterns. These are the patterns of what we believe an acceptable node and relationship would look like in the database. Once we describe these templates, you then go on and add further technical information. What kind of constraints do you want to add? Business rules, constraints. Do you need to define indexes? You want to document, what I call complex objects, or essentially paths. If there's a collection of, node and relationship types that are required to kind of query together to get an entire picture of an object, that's like a complex object, and it's a path in Neo4j terms. And then existence constraints, cardinality, these are all things that you can define. Now it's in some sense documentation, but it's important documentation to give to developers. So uh, so this is kind of a top down, and before you accuse me of being an ancient mainframe dinosaur waterfall methodology guy. Obviously, we don't try to do it all at once in this kind of linear fashion. You run your initial or small sets of use cases through this process, and then you rinse and repeat, and you keep going on to your next set of use cases, and you refactor as you go. And that's another bit of good news with Neo4j is it's easy to refactor. And in the relational world, a lot of times once your model gets created and set, it gets set in stone, and it becomes difficult to change. All right, so that's the process in kind of a linear fashion. So let's take a little bit of a deeper look at it now. And there's really kind of two flows that you can go through this. And the first is, this is the traditional schema first approach, and that's kind of this bottom arrow down here. But this is where you start with, you almost always are starting with an existing database or existing, Neo4j graph. But you're going to do some reverse engineering, some data discovery. You're going to look at, I've got Neo4j here, but maybe you've got a relational database, or you've got some flat file feeds, but you have to do some kind of reverse engineering and data analysis to get what data you've got coming into the system. And from that, you can lay out design templates. So now you can create your entity type, or I'm sorry, your node types. There I go, thinking like relational. I can't hardly control it. But you're thinking about your node types and relationship types. And once you've got a handle on that, then you can go ahead and create through some whatever application tools you have, you can start entering data and producing some storyboards to help validate your design. So once again, that's kind of the traditional approach. What's really exciting with Neo4j is that we can do this in the reverse. And this is really more the agile approach, and that's what which is really what we're after in a methodology. We're going to do a more agile approach. This isn't, and this you literally can't do this with a relational database. So we're going to start with instance data. We're going to create a storyboard, and we're just going to ad hoc enter nodes and relationships into the database. And we can do that because we don't need to define anything ahead of time. I find, this, when I'm working on a problem that it just doesn't seem clear to me what the solution is, this is the place to start, because you can just toy around with nodes and relationships and you can try different ideas until you get something you like. And you can validate with data queries. So once you get a storyboard or some instance data you like, then you can kind of go forward and create your design templates. So your node and relationship prototypes or templates, if you will, you can create that, and then you can add your constraints like we talked about before. You can further refine it, and then you can generate forward into Neo4j whatever. There are some, Neo4j does have some schema objects that you do create. So the various constraints and indexes. So that's this flow. That's the agile flow. And so the reality, though, when you look at these approaches, is you're going to kind of do both. You're going to go back and forth. There's always going to be some existing data that you have to analyze, and you really will do this in kind of a back and forth iterative fashion. right, now, so the question now is, can I just sit at my desk by myself and do all this work? And unfortunately, no, the answer is no. This is a very social process. So you really have to get out there and get with people. You have to bring people together and go through a lot of kind of meeting type work to get everyone to get a good design and to get everyone on agreeing that you've got it right. So what I've got here is a couple different tools that you can use. This chart here is trying to lay out for you your different user types, and notice it's kind of similar to the viewpoints on the Zachman framework. But you need to understand these different types of people have different needs. So, the business owner and management, let's be honest, management basically just wants to know if it's done. Okay, so did I say I've been doing this for 40 years and maybe I'm a little cynical? No. So they really they want to know, is it done and is it supporting my business needs? And then understanding what they need tells you how to pitch the right deliverable to these people. So at the business level, we just want to do, PowerPoints and high-level boxes and arrows. That's it. So our next view is all of our subject matter experts, our data analysts, data scientists, quality assurance people. So they really do want to understand the data. They want to know how to query it. They want to know what it means because that helps them do their job. And so for those people, we want to give them diagrams, instance data diagrams and the template diagrams. They want to see a logical dictionary, which is focused around the data meanings, data definitions. Developers start to get a little more technical. They care about these items as well, but they also want to understand, what's the physical schema, what's the business rule constraints that I'm programming against. And for Neo4j, this is really important because there's not a lot of business rule enforcement in the database. It's really up to the application developer to enforce all the constraints. So they want to see the diagrams too, and they want to see additional physical metadata like data types and things like that. The DBAs, they're more focused on what do I need to do to implement this thing? And, what objects do I need and when do you need it? So that's because they're generally running so many different projects that that's the type of help they need. So this is the point that as you're going through the process and you're interacting with these different groups of people, this is the different types of information that you want to deliver to them. And earlier, I posed the question, what exactly is a data model? And really the answer, it turns out, is it's really all of these things taken together. Now, the other thing that to pull from here is you're going to do this in using a lot of meetings. And so you really need to, there's a kind of a meeting style and a how you use tools kind of style to these meetings. And you really need to match that to the life cycle. So your initial meeting, really you're just doing ideas, brainstorming. That's when you want to use markers on a whiteboard. And really a paper and pencil or a marker approach works best. Don't try and start with tools here because it's just you're gonna get bogged down, especially when you've got subject matter experts in the room. They really don't want to see you trying to use some kind of a technical tool. So after you do your brainstorming and you've taken a good shot at it, now you're going to do some follow-up confirmation meetings. And here I've done kind of a hybrid approach. I'll come in with my modeling tool and I'll project diagrams up on the board, and then we might take markers to the diagram that we're projecting. So make sure you're not projecting on a screen, you're on a whiteboard. But But that works well because you're still kind of thrashing out, what is this working or not. Then after you feel you're doing well there, your next kind of meeting is going to be review. And here you want to come in with handouts, your diagrams, your metadata, dictionaries, handout and walk through. Typically, you're doing most of this with your SMEs, data analysts, developers. So obviously review, the idea is to gain people's concurrence. And then if management, if you're going to have a meeting just with management, like I said, stick to high level stuff. They don't want to see the diagrams. But actually, it doesn't hurt to kind of flash a couple diagrams in front of them because they like to see that you've got some detail. They just don't want to go through it. Okay, so and finally, publish your results. This is I've proven this over and over again. Take your diagrams, your dictionaries of definitions, put them out there on an intranet. Email them to your developers, your SMEs. They love this stuff and they will use it. So you get a real benefit from doing that because it's not just something that gets shoved in a drawer. That they'll actually use this documentation. All right, so there's a lot on this chart, and this is a lot of good, actionable kind of best practice stuff here. So, at any rate, okay, moving on. So just to summarize, you have a data model, whether you realize it or not. You can proactively decide that you're going to create something and work on it, or you can just let it evolve ad hoc. But at one way or the other, you do have one. So it behooves you, I believe, to try and do a more formal job with it. Model the data meeting. What, not how. Work from the design view. Remember, we're translating business needs into a graph design that the developers can take and be successful with. Bounce around between instance prototypes and the schema template design. You're going to go back and forth. And then finally, remember, this is a social process. We're trying to match the deliverables to the user and match your meeting style to the kind of where you're at in the life cycle. Okay, so I'd like to do a really brief demo here. We got a few minutes, and I want to show you kind of in action, how you can do this data prototyping, this instance data prototyping, and then switch over to template designs. And so the use case here is very simple. We're just going to model an order that has line items. Very simple example. And so this is Nodera. It's a data modeling tool. And it starts out empty screen. So we're going to connect to a database. So this is my local host, Neo4j. So this is the schema editor, but we're doing design work. So we're going to create a project, and we want to do a storyboard. And so that we do that on an instance diagram. So we have no design. We're just, going to freeform, enter some nodes and relationships for our concept of orders that have line items. So let's go ahead and create a node, and we're going to have an order label for our first node type, and we'll add some properties. So probably a good idea to have an order number, integer, and then we'll just give it a data value. Remember here we're actually entering data in the database. We're not designing a template. So there's an order node. Okay, let's go ahead and let's create a line item. So once again, we're going to create a label. We'll add a property. Probably should have an item number. And so we'll create item number 1 for this order. Orders hopefully have more than one line item, so now we've already entered the labels and properties, we can just pick them. And this will be item number 2. All right, so now we've got 3 nodes in the database. Of course, what's missing is a relationship. So orders have line items. So let's create a relationship from order to line item. And we just need to give it a relationship type. Has line item. So an order has line item. And there it is. Go ahead and enter another one. And now we have it. So there's our instance data prototype. So you know what? I'm looking at this. I'm feeling pretty good about it. I like the design. Seems to answer the questions I want. So let's go ahead and create some design templates from this. And really, we're just using the actual instance, the actual node as a prototype to define the template. And the way we do that is we go ahead and open that node, create template, give it a name. We're going to call it order. Okay. And do the same thing for a line item. And it's associating these nodes with the template. We'll create a relationship template too. Give it a name. If I could type. All right, so this, we just need to associate. We've already created the template. Let's just associate this node with its template and click OK. So now we've generated the templates and based on our instance data. So now we want to go in and let's further refine some of this. And we can create a diagram with just our templates on it. Let's do that first. And it's easy to add. You can just drag them on here. So we'll bring the relationship on here, and that brings the 2 node templates. So here we have our design. We have an order node that has line item nodes. So we can go into the relationship and we can define cardinality. So an order has 0 or many line items. And a line item actually really belongs to one and only one order type or node type of order. So now obviously this is just documentation because there's nothing in Neo4j that's going to enforce that constraint, but it's important to tell your developers that. All right, now let's go into the template for the order. You know, I think an order date would be good. So we can define additional properties in the template. We can create constraints. This is probably a good case for a node key. So we're going to add a constraint, pick our label, pick our property list for the node key, and you'll see below that it's telling us we're going to get an index generated automatically. We can go and add descriptive information about this node, the order node. And then finally, since we defined it, there's a data grid. So you can actually edit the data. We added that order date property. Let's go ahead and add an order date to that one node. We can create new nodes. We can delete them. So this is a simple data entry capability based on the node template. So now you see the order. So here's once again, we've gone from our instance data prototype and we've generated a template design. And we've enhanced that with constraints, which show here we added additional properties. So finally, we can take this, we can forward engineer all the schema objects. Like I said earlier, there are some schema objects that you create. And so here's that node key constraint. And this is the Cypher query. We could run this query and we'd have that constraint. So that's the demo. I'm going to switch back to the slides. And we've got the Hunger Games, and we've got your questions, if any. So okay, so here's your Hunger Game questions. Easy. Do I have to do a data model? And here's your two choices, your two answers. Your medium question, what am I trying to model? And your three choices are why, how, and what. And then finally, what does management care about the data model? Well, they care that the data model defines the correct data meaning. Do they care that all possible conceptual data constraints have been defined? Or do they care, is it done yet? And once again, if you're playing the game, there's the website to go and put your answers in.
Hi, John. You've got some questions
Okay.
as well.
Hi, John.
In the
I've got
Q&A
some
section.
questions as well in the Q&A section.
Okay. Can it export a GraphQL schema? That's a great question. It doesn't do that now, but that's on the radar. So send me an email. Would love to hear more about what your use case and what your needs are. Next question, is there a way to generate and store test data based on the design templates, i.e. create 100 order nodes with random data? So you can manually key it in. You get a simple data grid to do that. But the automatic generation, that's another that's on the list, and that's another idea that's coming soon. Okay. So that seems to be our questions. I hope everyone enjoyed this. It was actually the next talk coming up. Max is going to talk about Max DeMarzi, I think, if I got his name right. So it's a good follow-on to this presentation. He's going to talk about property graph design, probably some do's, don'ts, best practice. So is it Windows only? It is now. The Mac version is coming out soon. Yeah, there we go. Data modeling tips and tricks. Max DeMarzi. Yeah, that's a good follow-up to this one. There's no additional questions. I really appreciate everyone being here. And once again, we'd really love it if you